Incorporating digital technology is essential for our society to accelerate the systemic shifts needed to create a circular economy. Especially in the new post-COVID reality, technology will facilitate greater knowledge and collaboration, better use of resources, and improved well-being so we can achieve our economic, environmental, and social goals. I welcome to the Circular Economy Forum Shyaam, Ramkumar, circular economy expert, and TondoLAB. Hi, Shyaam. I hope that I pronounced your name not that bad.
It was great. It was perfect. Can you all hear me okay?
Yeah, sure.
Okay, perfect. Yeah, thank you very much for the introduction. Let me go ahead and share my screen here. Can you all see the screen?
Sure, yeah.
Okay, perfect. Indeed, so what my talk will focus on is kind of looking at how digital technology can form a roadmap to enable the circular economy, kind of building as well on what Davide presented in the previous talk. So just a quick background about myself. My name is Shyaam Ramkumar. I'm from the United States. I have a bachelor's in economics from Northwestern, and I worked as a consultant in Accenture for a few years. Then I came over to Europe to do my master's in industrial ecology, after which I interned with the Ellen MacArthur Foundation and was also the knowledge and innovation manager at Circle Economy. I moved to Milan to start my PhD in economic sociology and circular economy eco-innovation. And while in Italy, I got involved with Tondo, and I'm the circular innovation expert there, and also helped co-organize a circular economy club in Milan. So yeah, indeed, like as Andrea kind of introduced, what we're seeing is sort of an increasingly digital world. Since the latter half of the 20th century, we've been living in this digital age. And if you look at the 1980s, for example, less than 1% of the world's information was stored in a digital format. And by 2014, it was more than 99%. So a huge exponential increase in the prevalence of digital technology. And now we're sort of entering this fourth industrial revolution with incredible advancements in different kinds of technologies, AI, digital fabrication, gene editing, sequencing, et cetera. And this is starting to become the new normal. I think this year, especially with the novel coronavirus, we've sort of seen this accelerated trend towards a more digital society. Because of the health risks of the virus, we've been increasingly moving towards online learning, online working, online socializing, et cetera. And this has huge implications for governments and companies and citizens as they sort of get used to this digital normal, this new normal in a post-COVID world. And this increasing use of digital technology is actually a huge positive trend to enabling the circular transition as well. Technology allows for greater knowledge sharing, collaboration, insights and analytics to support the better use of assets, and improved well-being for all. And I have this image here of the Disrupt framework from Circle Economy, where they kind of highlight 7 areas that are important for the circular economy. And you'll notice that the second one, especially, is focused on digital technology and how resource use can be optimized and connections can be strengthened by using digital online platforms and technologies to increase the connections between supply chain actors and companies and other stakeholders. And the digital technology landscape can be seen as sort of having some building blocks as well to enable the circular transition. And today I'll focus on 4 kinds of technological solutions and how they are contributing to the circular economy, but also how they are connected to each other as well and can kind of build on each other. So looking at digital platforms, looking at blockchain, big data analytics, and artificial intelligence. And starting with digital platforms, they kind of form a foundation for enabling greater connection and collaboration to advance the circular economy. There's a lot of these platforms that have been developed recently, and through them, companies and governments and citizens are able to exchange knowledge. They're able to share assets, reduce transaction costs, and some of the inefficient market failures for secondhand resources, for waste resources, for products. And they can also identify joint opportunities through these platforms. And the constant use of these platforms is also generating a lot of data and insights in terms of patterns of use, sources of waste, and sort of the demand and supply of secondhand goods. And an example of that is for example, Flow2, the online marketplace that enables asset sharing between companies. So using this platform, companies can increase and valorize their existing assets, but also services and knowledge and skills by sharing them with other businesses for a price. And the platform really opens up new opportunities for collaboration between companies and is gathering data on what are the biggest resources required, who has the biggest needs, and who's sort of able to provide them. And then if you think about building on these platforms, it's important to sort of manage and store all this information in a secure way, but also provide them to the different stakeholders. And that's really where blockchain can provide this sort of distributed, decentralized way to manage and store this information. And doing so really allows for greater transparency in terms of the origin of products, resource use, authentication of products and security, tracing different supply chain issues, et cetera. In addition, digital tokens through the blockchain can also incentivize positive behavior by companies and by consumers to really drive that circular transition forward. And we see this with this example of Bext 360, and they're a company that used blockchain to make the coffee supply chain more transparent and socially responsible. So they installed these Bext machines in different farms and entered the information of the coffee beans that were harvested into the blockchain. So they basically graded these coffee beans based on quality. So you can identify which farms had high quality beans and which farms didn't and needed to work on it a bit more. And it also allowed them to kind of trace where the coffee beans came from, which roasting company it was sent to, and ultimately how it ended up in consumers' hands. And moreover, by tokenizing these beans, the company was able to very quickly pay the farmers in cryptocurrency. So it provided really fast and more equitable payment solutions to these farmers, which is a big problem in the coffee supply chain. And then, with all this data that's generated by these platforms, but also by the Internet of Things, et cetera, and stored in the blockchain, there's a need to sort of analyze it. And through big data analytics and the use of these advanced analysis techniques, it's possible to kind of go through these large volumes of data using text analysis, data mining, predictive analytics, machine learning, et cetera, to identify these patterns and see how to optimize resources and optimize our use and production of products and services. And an example is this company, Intelert. It's a company that provides data science and big data analytic solutions. And in this example, they kind of worked with a Dutch city, the city of Zaanstad in the Netherlands. And what they did was they looked at over 136 million records of housing data. With the Netherlands especially, there's a lot of the buildings and housing are built on wooden piles. And these foundations need to be constantly repaired and maintained. And the city was having a bit of trouble managing how they should devote resources to maintain the foundations for a lot of these buildings. So they developed this predictive model using all of this data and identified which buildings in the city are at risk of foundation damage using things like weather data, soil data, the building stock data, et cetera. So they brought together these different databases, and this predictive model was able to indicate how the city should devote their resources and time to make sure that they take care of buildings that are at risk for foundation damage and didn't have to waste a lot of money doing everything without this knowledge. And then lastly, there's a lot of really nice advancements in artificial intelligence that can really build upon some of these capabilities with big data analytics and develop computer models and algorithms that are able to learn from experience, similar to the way people do. And this really enables things like having designers use AI to design products in ways that people couldn't imagine, using generative algorithms, retailers using dynamic pricing, using AI to identify which of their stock is going to be going to waste and how they can reduce those prices to make it leave the shelves quicker. Looking at automation for manufacturing or sorting or disassembly of products in a more efficient way. But even entire cities could be redesigned to be less environmentally harmful and more socially equitable by seeing all these different patterns of usage and all this information from various sources to identify how to kind of zone different areas or where to place new buildings, et cetera. And an example of a company using AI effectively is Zen Robotics, and they essentially developed an automated waste sorting and management system, and their AI system is called Zen Brain. And what it does is it analyzes waste streams using sensors to direct heavy-duty robots to make decisions on how to sort the waste based on material type or color or shape. And this really allows these waste streams to be sorted much faster and more efficiently compared to the more manual processes that are used, making it a much safer option, a much faster option. And you know, once these waste streams are effectively sorted, it's much easier to find new uses for them and to recycle them more effectively. So yeah, just highlighting how, you know, there's lots of technologies that can kind of build on each other. And I think there's rapid advancements in each of these technological areas. So there's lots of solutions being developed with digital platforms, with blockchain technology, with big data, with AI. But a lot of them are really happening in silos. So it's crucial to identify these interlinkages between these different technological solutions so they can more effectively support the circular transition through a more sort of coordinated roadmap. And this is really something that the European Policy Center and the European Commission are recommending. There's a report that was released by the European Policy Center called the Digital Circular Economy. And it highlights how, you know, there's a strong interplay between the digital agenda and the sustainability or circular economy agenda, and identifying how those interlinkages can cross-fertilize each other and build upon each other in this feedback loop is really essential to ensure an acceleration of the circular economy. And it's sort of a critical component as well of the European Green Deal. So in kind of conclusion, it's really important, I think, to identify how these technologies can really come together to support a more circular transition, rather than just kind of building solutions in silos, but also more importantly, making sure that these solutions actually do enable some of the circular developments and sustainable developments that we want in society, rather than making our linear economy more efficient. Thank you very much.
Thank you, Shyaam. We actually have a question for you from Bruno Rudnik. And he asks, in which areas of the circular economy, for example, waste, water, environmental monitoring, etc., do you see the greatest potential for artificial intelligence technologies going forward?
Yeah, that's a really good question. I think I've seen some really amazing examples of the use of AI across all these different areas. There was a group that I think developed something called, for example, Ocean AI. So it used satellite imagery to identify where boats were kind of dumping waste illegally in oceans. I think there's a use of a lot of technologies to identify, using satellite imagery again, where like water leaks are happening in different places to help cities and farmers manage their water better. With waste, indeed, for example, Zen Robotics and other companies are developing ways to more effectively sort and manage waste. So really a lot of the power of these technologies is that they're applicable in a lot of different situations, a lot of different industries. And of course, some industries are more accepting of them than others. And I think there's really a mindset shift that's required to help organizations in some of the laggard industries really come up to speed, because the utilization of these technologies can really not only improve their bottom line, but also do it in a more resource efficient and resource effective way.
Very well. Thank you, Shyaam. Thank you for your presentation and also